Good morning, everybody, and welcome to the Retrofit Academy's Ventilation Summit. This is our final event of the year, and it is a free-for-all session. We do run some sessions throughout the year for our members, but this one in particular is for everybody, a fully inclusive event. We want to get as many people in the room as we possibly can. So thank you very much for joining us. It's really appreciated. I'm Andy Johnson, and I'm the Network and Membership Manager here at the Retrofit Academy. So again, thank you for joining us. I'm just going to take you through our slides. Hopefully you can all see this. We've got a fantastic panel here today. Obviously you've got myself, we've got Alan Pither, who's our Technical Director, Simon Jones from Aereco, we've got Toby Cambray from Greengage, and Adrian Hull from Retrofit Solutions. We are hoping to have Dr. Peter Rickaby with us, who's also one of our Technical Directors, but unfortunately Peter may not be able to make it. So apologies from Peter. A very short sort of last minute family emergency came up, so Peter may not be with us, but if he does, obviously look out for Peter as we go through. So just a very quick sort of run through of what the agenda is going to be like today. We're not planning to have any breaks. We are going to go right through on the 2 hours. The way we're planning to do this is the first hour will be with all of our presenters. So first of all, I'm going to do a very quick introduction to the Retrofit Academy for those of you that don't know us. Then there'll be a section possibly with Peter, but if not, Alan is going to cover both that and his own section at 10:15. Then we'll move on to Simon. Then we've got Toby, and then we're going to go with Adrian for the final of the speaker sessions. And that's then when we'll open up to the second half of the summit, which will be the final hour, and that'll be a questions and discussion session with you all. So what I'd probably propose, if it's okay, is that you can try and do your best to refrain from putting any questions in the chat until that second hour. Obviously, keep a mental note of them, write them down, but if you can then start posting them as we come toward that second hour, that'd be great, and just really help me and my colleague Emily to facilitate those questions. And if you've got anything particular for one of the speakers, if you can just use the @ symbol and then just put their first name, just so we know if that question's being directed to that individual or individuals, again, that will help us to make sure we can put that right to the correct speaker in the room. So very quick introduction to the Retrofit Academy for those of you who are not familiar with us. So the Retrofit Academy is a community interest company, and it's something we are extremely proud of. And we are one of the leading edge training providers of professional development to a whole new generation of retrofit professionals in the UK. And our vision is a world where every home is warm, healthy, and low carbon. And hopefully the reason that a lot of you are coming to these summits and to our sessions is because you fondly believe and firmly believe in that too. So our mission is to enable an army of retrofitters to deliver 27 million retrofits over the next 30 years. It's a huge challenge. I don't think anyone can sort of deny that, but obviously with your support, with your help, and with some guidance from ourselves and our fantastic network of professionals, we're really on course to try and hopefully deliver that. So our aim is to drive past 2035 compliance by shaping retrofit best practice, sharing our technical expertise with industry peers, and advancing the sector through our memberships. So we have got a membership program as well, which is something that I lead on within the organisation. So if you're looking for any more information regarding our training courses, regarding our membership, then please go to our website, retrofitacademy.org. Just a couple of real quick points before we go to our speakers. If you're not aware, we are actually going to be running our very first ever Retrofit Academy Awards next year, something we really sort of strongly believe in. It's not going to be one of these black tie events or sit-down dinners, very informal, but the real sort of focus for us and emphasis for us is recognising excellence in retrofit. And that's everything from retrofit coordinators, installers, social landlords, particular projects that are being run that really sort of show sort of excellence and really leading in the sector, as well as those rising stars that are really emerging and showcasing the best of this sector and what it has to offer. If you're interested, the closing date is the 14th of January, so that's whether or not you want to put a submission for yourself or nominate somebody else. Please be aware of that really tight deadline, and you can go to our website and go to that URL where you can have a look at our page. I'm sure myself or Emily will put that in the chat as well, so you can have a very quick link to go to that page, but we'd love for you to get involved. And these awards will take place at Future Build next year, one of the biggest UK construction build and energy efficiency events in the UK. It takes place at London's Excel, the 1st, 2nd and 3rd of March, but the awards will be straight after the first day of the Future Build event on the 1st of March, which is a Tuesday. And the final thing from me is regarding funding. So Anyone that is currently working or has offices or colleagues based within the Manchester area, we have still got some funding available. It's fully funded training for retrofit level 5 coordination, as well as some of our newer courses we've got available as well. We're planning to sort of train up to 600 people before July 2022. Details of that, again, is available on our website. And we're also pleased to announce that we're also soon to be offering fully funded places in both Devon and Essex as well. So please look on our website, please look at those details, please share it with your network. But if you do want any further information, you can email the training team, info@retrofitacademy.org. Okay, thanks everybody. That's enough from me. I say at this point, I would have been handing over to Peter, but unfortunately, Peter can't be with us this morning, possibly may join us a little bit later on. So for the time being, I am going to share my screen with Alan Pither, who's one of our technical directors here at the Retrofit Academy. And Alan will be going through the first couple of presentations. So thank you very much. I am going to mute my screen and I'm going to hand over to Alan Pither. So Alan, over to you.
Thank you very much, Andy. Good morning, everyone. Yeah, welcome to the summit. And first of all, just apologies in case I don't fully do justice to Peter's presentation. I obviously didn't know I was going to be presenting these slides, and I've seen him talk around the subject many times, but I'm not sure exactly his train of thought when he was putting this together. But I will do my best to give you a summary of what he was planning. So first point, we're all familiar with the phrase "no taxation without representation," whereby clearly people aren't going to be prepared to pay taxes if they don't have a say on who's deciding on what taxes they should pay. So in parallel with that, we have a phrase, no insulation without ventilation, which should appear on the screen if this is working well. There we go. So no insulation without ventilation is the theme of the day, really. Again, I'm not, hang on, let's move this on. Sorry about the lack of slickness here. So two purposes of ventilation. One, to remove stale air, which may be considered polluted, depending on the conditions in the home. And the second, to replace that with fresh air from outside to replenish oxygen levels and so on. So that's very, very clearly the two main purposes of ventilation. And without ventilation, we get problems. The buildings deteriorate. Moisture in particular is likely to build up, and then obviously there's risks of condensation, mold growth, rot, and corrosion, which certainly over time are going to cause significant problems to the building and require significant interventions to put right. There's also an impact on the occupants. People become unwell and eventually die. So yeah, and there's a number of potential pollutants as well as moisture, carbon dioxide, volatile organic compounds, and so on. And of course, there's health problems associated with mold in particular. The mold spores, a trigger for asthma and other respiratory diseases. So we cannot ignore ventilation in our homes. So when we're looking at older buildings, certainly before the 1970s, all homes relied on aerial filtration driven by the wind primarily, perhaps to some extent by the stack effect as well. And so that would drive air in, and then you get exfiltration or leakage, obviously to balance the pressures on the opposite side of the building from the wind. And there would also be other drivers of ventilation, in particular open fluid appliances, which obviously draw the air through as well. And generally the fabric was leaky, very permeable to air, so there was no barriers to that ventilation occurring. From the 1970s onwards, we started to frequently or more commonly replace windows. We started to be concerned about reducing energy costs and draft sealing. Draft sealing doors and windows was a big part of that. Obviously that reduces infiltration. And one of the unintended consequences of that was increased incidence of condensation and mold growth, especially in wet rooms, kitchens, bathrooms, etc. And so to address that, intermittent extract fans were introduced, and background ventilators to provide air inlet to balance the pressures. And so that helps, but fans are very intermittent. They're not often run for very long each day. So they're not necessarily going to help the rest of the time. And obviously the background ventilators will have some benefit. So most of us are still living in old homes, which are still reliant on that air infiltration and leakage. 75% of homes are probably still in that situation. Obviously, newer homes are built more airtight and with ventilation systems very often, but even some of those are not necessarily using whole house ventilation systems even now. And the key point is that any insulation measure, whether it's the floor, the wall, the roof, is going to reduce air infiltration and air leakage. Even if you're not specifically trying to reduce the air infiltration and air leakage, you're just focusing on the insulation. And obviously that's not good if you do, but even if you do, you're going to reduce the infiltration rate, you're going to reduce the air leakage rate. And that risks reducing the internal air quality because the ventilation will no longer be adequate. So consequences, significant increase in condensation and mold, and that's leading to the fabric deterioration, as I've already said. Increased risk and incidence of respiratory disease, and that's particularly significant in terms of vulnerable elderly people and young children. They're going to be particularly at risk, and it's going to be exacerbated by fuel poverty. If the home is underheated, then that will lead to higher relative humidities and higher risk of condensation and mold. And so, and also people are going to be concerned about running ventilation systems very often if they're conscious of the cost of the energy they're using. So the solution is to design in more deliberate ventilation to replace the lost infiltration. And there's many options now for continuous mechanical extract ventilation. With continuously running fans, it's going to be much more effective than the intermittent fans, and where you can incorporate heat recovery, clearly that will help to save energy, so long as the heat recovery efficiency is high enough to counteract the cost of running the fans, which modern systems will be. So for energy efficient, healthy homes, what we need to do is build tight, ventilate right. And that's been in BRE guidance since the 1980s. And PAS 2035, as you know, is also supporting that approach. And so we need to control the extract and the supply of air in the homes, and minimize accidental, uncontrolled infiltration and leakage. And we need to avoid introducing perverse rewards for retaining high air permeability. So I guess Peter's thinking in terms of potentially improved energy ratings on EPCs for high air permeability. Now, high air permeability will be air leakage, so that's a different point. I think, yeah, sorry, I'm off the top of my head, I'm not quite sure what Peter was looking to pick up on there. Anyway, so overall, the key thing is that no insulation without ventilation is the key theme when we're planning retrofits, and build tight, ventilate right in terms of the design of the system. So moving on to the part I was going to do anyway, that is to introduce or remind you of the requirements for ventilation that are written into PAS 2035. So obviously that's what's driving us now in terms of planning retrofits, and there are all the details are in Annex C of PAS 2035. So that's the source of all this material, and you can obviously refer to that when you need to check the details. There's a lot of references to approved document F, part F of the building regulations in Annex C. So it does lean on some of those standards, or refer to them, for example, for the size of background ventilators. But some of the requirements in PAS 2035 go beyond approved document F. So that's something to bear in mind. It's not sufficient to meet the requirements of approved document F. So key requirement, when installing any insulation or air tightness measures, the adequacy of the existing ventilation must be assessed, and if necessary, then improved. So the retrofit assessment needs to include a ventilation assessment every time, and insulation or air tightness measures obviously include any sort of insulation or draft sealing work, but it also includes window replacement, because window replacement inherently will also reduce the air change rate in the property, and that's irrespective of whether the original units were draft stripped or whether you've got background ventilators in them. It would also include replacing an open fluid appliance with a room sealed one, because that again is going to reduce the air change rate within the property, and likewise sealing up any flue or chimney. So a little bit more detail on the ventilation assessment. The C2.2 is where the 4 criteria are listed. So the first one is that these are the criteria for the ventilation being inadequate. So if there's any condensation or mold growth in the dwelling, that is indicating that the ventilation is not adequate for the situation. Obviously, if there's no ventilation system, can't be adequate, but also if the system's incomplete or not functional. Third one is that there are no undercuts between all internal doors. So that's important to allow air to move through the dwelling. And the final one it relates to purge ventilation. So there should be purge ventilation in every habitable room as required by approved document F. So that's the full ventilation assessment that applies for risk paths B and C. If you're looking at a project with risk path A, there's still a requirement for ventilation assessment, but there's slightly less onerous. But in my view, there's not actually a great deal of difference, because you still need to look at the location and severity of any condensation or mold growth in the property, and you need to record the details of the ventilation system. So you're still doing the first 2 of the 4 points above. So it's only really the undercuts and the purge ventilation that you don't need to look at in the case of Path A. So there's also a list of definitions of complete ventilation systems, and this is actually quite a long list. So I've tried to distill it down into the key points. So if you're looking at intermittent extract ventilation, passive stack ventilation, positive input ventilation, or mechanical extract ventilation, so any of those types of systems, you need correctly sized background ventilators in the living spaces and bedrooms as well. And as I said, the sizing of those is detailed in, is consistent with what's required in approved document F. And the other consideration is that IEV or PSV might not be adequate if improvement measures are intended to reduce air permeability below 5 cubic meters per square meter per hour at 50 pascals, or might do so. So that's obviously an important consideration if you're doing you may need to introduce at least MEV in that situation. The other option, of course, would be whole house mechanical ventilation with heat recovery, where you have fans supplying air as well as extracting air. So that's a good solution from a number of aspects, but obviously has significant cost and sometimes logistical implications in terms of the retrofit project. If the ventilation is inadequate, then you have to include a ventilation upgrade in the project if any insulation or air tightness measures are proposed. If there aren't any insulation or air tightness measures, then it's not a requirement to upgrade the ventilation, but that upgrade should still be recommended to the building owner or the client, and it should be included in the medium-term improvement plan if they do not choose to follow the recommendation. And ventilation upgrades, there's a few more sort of conditions in the in Annex C. Demand control is required for MEV, PIV, or MVHR. Simon Jones is going to talk a lot more about that in a minute, so I'll leave that to him. And there's next requirement is that single room heat recovery ventilators are another option, but they should only be used to supplement a new or existing ventilation system, not introduced as a whole house system, so not several of those as a whole house system. And then the final point on this slide, flexible ductwork should only be used for final connections to fan boxes, extract grills, or terminals. So rigid ductwork is much more efficient in terms of allowing a free flow of air and reducing the fan power needed for the system. So finally, I think there's a number of confirmations required, and those of you who've been using our software templates for recording your projects will be familiar with this list. There's a checklist on the ventilation screen, so I'm not going to read the whole of this out. But there's 8 points there that as a retrofit coordinator you need to check are included in the design to make sure that it's compliant with PAS 2025. So I think that brings me to the end of my slides. So at this point, I'll hand over to Simon Jones.
Very quickly, thank you very much indeed, Alan. Yeah, I'm going to hand over to Simon now, but just a very quick virtual round of applause for Alan for not only doing his segment, but also for covering for Peter at very, very short notice. So it is very much appreciated. So thank you very much indeed for that. So yes, I am now going to take back control So thank you very much again.
Good morning, everybody. What I wanted to do really was, rather than discuss the technical aspects of demand control, I really wanted to try and give an overview of why it might be being talked about in the context of retrofit and PAS 2035. What we're trying to do with retrofit, obviously, particularly under PAS, is provide a responsible whole building retrofit work that's improves both functionality, usability and durability of buildings, provides comfort, health and well-being for buildings, but also balances that with energy efficiency and avoids unintended consequences. And that's quite a tall order for any building. We also lay on top of that, we're not completely sure about how journeys in buildings are going to progress. We often think in terms of whole house retrofit at one single project or one single period of time, but often we're taking buildings on a journey over many decades with retrofits, and we can never be sure what's going to happen next. If you wouldn't mind going on to the next slide, please. So whatever ventilation system is adopted within retrofit, there's a couple of things that we're asking it to do every single time. One of it is to provide a whole dwelling background ventilation rate, and that's derived from trying to manage often pollutants that are generated by the building itself. But we also then try and provide a rate that covers the amount of people that are in buildings, so the amount of pollutants that we may put in, and that's where we assume a certain occupancy level based on bed spaces. We also are looking for a certain amount of capacity in ventilation systems to be maintained throughout the year. What often is not appreciated is that there can be different demands on a building depending on the seasons that it's going through. And then we also ask it to intermittently achieve higher flow rates based on specific activities in certain rooms. So we're asking a ventilation system to do an awful lot, actually, and getting that right can be very difficult. And that's one of the reasons why in PAS, and we often see in all sorts of building control documents now, or building regulation documents, the use and the term of automatic control over ventilation systems, so that we can provide some sort of degree of control to react to different circumstances. So in PAS, we talk about the whole house ventilation rate should be controlled automatically so that it can maintain both good indoor air quality and avoid wasting energy when higher rates aren't required. Control should be provided that sense and monitor a control parameter, typically an indoor air quality parameter, that can automatically regulate the ventilation rates, either on a room by room basis or on a zone basis, or even at a whole house level. Next slide, please. So this is what we're talking about when we refer to demand control. It's a system that complements the provision of adequate capacity and ventilation in a house by providing a certain degree of variability to the system. Control parameters are parameters that measure indoor air quality parameters that are indicative of indoor air quality. So, for example, relative humidity, carbon dioxide, volatile organic compounds, and other things. Next slide, please. So, if you think about it, every room in every house, every zone in every house itself will have a rising and falling demand for ventilation. And that's what this blue line here is on this graph. It could be a bedroom where we go to bed at night, we sleep there for 8 hours, we get up in the morning and go to work, we come back the next day and go back and sleep. This could be a kitchen where we get up in the morning, we cook breakfast, we create pollutants, we go to work, we come back, we cook dinner, and so on. This could be a house where we're talking about people coming and going from work and school. The point is that it's not a fixed line. And what we're trying to achieve with fixed systems is a guess. We're trying to guess what that rate should be. And that's where we see 0.3 litres a second talked about, which is a flow rate based on the floor area of a dwelling. It's where we talk about the amount of people per bedroom to try and guess how many people are going to be in there on average. It's where we talk about roughly how much we should boost in a bathroom. the point is a bit like a broken clock. It's only going to be right twice a day. And similarly with ventilation with a fixed rate, there's only going to be certain points in the day where that ventilation is correct. The rest of the time, it's either going to be underventilating or overventilating. And the gamble, the game with fixed systems is to pick a rate that best covers all bases. If we set that too high to cover indoor air quality, then there's going to be larger periods of time when we're overventilating potentially. And of course, if we reduce that rate to try and minimize heat loss or noise or energy use, there are going to be longer periods when we're underventilating. What we're trying to do with demand control ventilation is follow that curve regardless of where those indoor air quality parameters take us. One of the other things that's not appreciated with demand control, and this is why we talk about capacity in this particular presentation, is if you have a system that has to go both well above and below the regulation flow rates, you also introduce an inherent capacity into that system. Just one simple example of that, one of our extract grills that would typically go in a bathroom would range from anything from 4 litres a second all the way up to 18 litres a second, which gives you enormous capacity within a ventilation system to meet a range of demands. Next slide, please. And why is this important? Well, if you think about where we are with most systems, and when we look around Europe, and the UK is not alone in this, we find typically well above 60% non-compliance to meet minimum standards for ventilation. And there's a reason for that. When our ventilation approach is fixed, so when we have to pitch a guess, when our building standards are minimum based building standards, so we set a target of the minimum that should be required. When we have manufacturing that's rewarded for lean production values and meeting energy standards above anything else, when ventilation is seen as an expensive add-on and not considered as an intrinsic part of a build, when projects are constantly cost optimized and value is sought, when skills are poorly defined and labor is under pressure, and when the policing of ventilation and accountability is weak, what we find time and time again is any break in that chain, by the way we've set that chain up, means you're automatically not going to meet that minimum standard. And that's the challenge. And that's why capacity is such an intrinsic part of both ventilation, but also retrofit in general. Capacity is a huge part of making sure that we're able to cover more bases. A good example of that really has been the last couple of years. Nobody ever expected when we were retrofitting buildings or building buildings in the last decade that people will be spending so much time at home over the last couple of years. And I think people have really become very aware of the capacity and the ability of their ventilation systems to provide adequate air. Next slide, please. So what the demand control approach does, by having an approach that enables you to go well above ventilation flow rates and below, if safe to do so, is it brings an inherent capacity and flexibility into ventilation. The product, the ventilation design, the installation and commissioning all now has to take into account the needs of not just to go below or to fixed rates of ventilation, but also well above them. And that means everything has to change. The ventilation design has to think in terms of ventilation rates above flow rates. Ductwork design has to take account of that. How it's installed and commissioned and managed has to be taken into account. And what it means is we're never reaching for that minimum standard, and you're far less likely to fall short. And it has the capacity to meet and change with demand over time. And I think that's why it's such a powerful tool, particularly in retrofit, when we don't know the journey a building is going to go on. That's it. I think that's my presentation finished. Thank you.
Okay, Simon, thank you so much for your presentation. Really enjoyable. Yeah, really interesting. And no doubt there's going to be some questions that are going to be coming through at some point in the chat. But again, just a very, very quick reminder regarding that. If we've got any questions, if we can do our very best to try and refrain from actually posting those in the chat until we get into that second hour, that'd be amazing. And again, if you want to direct a question specifically at an individual, then please just use the @ symbol on your keyboard, then use their first name, and we can at least then try and do our best to direct the question to that particular speaker. Okay, fantastic. So next up, we have got Toby. So Toby, I'm going to hand over control to yourself. Again, by the looks of it, I think we're going to have me doing the next slide, please, for you. So more than happy to do that, Toby, but you are now in control as much as possible. But let me know when you want me to flick through the slides, and I will, yeah, change those through for you. So Toby, over to you.
Thanks for that, Andy. Okay, so for those that don't know me, my name is Toby Cambray. I'm a founder and director at Greengage. We're a mechanical electrical design consultancy and building physics consultancy, and I lead the building physics team. So I have done a fair amount of ventilation design. I don't really consider myself a ventilation expert, but yeah, have some sort of insight into this. And the yeah, I'm more on the physics side of things, in particular moisture risk, which is obviously very relevant to the ventilation topic we're talking about today. Thanks, Andy. So yeah, I'm talking about positive input ventilation today. Invited to speak on that topic. It's something I've sort of stumbled into and become kind of an accidental expert on that. Not really an expert at all, but I saw an advert on TV a few years back, which annoyed me a bit, and I thought it was a little bit misleading. So I wrote a blog about that, and did a bit of analysis and a bit more reading around the subject. Also turned that into a webinar for the AECB, and that's still available as a recording. So if you want the kind of long version of this, then go and have a look at that. You do need to be an AECB member. It's the members area, but I'd encourage you to consider that as well, not just for my ranting, but it's a really great organisation with lots of useful information on retrofit. Yeah, so just to kick off then, this is the kind of units I'm talking about today. There are sort of variations on this theme, but these are the kind of three kind of typical ones. Names have been removed to protect the innocent. Is there everyone else kind of hearing me okay?
Yeah, I can hear you, Toby. Yeah.
Okay. I'll persevere. Okay, so yeah, there are variations on this theme, but the most common ones, as I understand it, are and the ones I'm generally talking about today, are the single fans that sit in the loft, draw air in from the loft space, and blow it into typically the landing or pool area. Yeah, as I said, there are sort of a few different types, multi-point ones, ones with a sort of loft bypass duct, but yeah, we haven't really got time to get too deep into specifics today. Next slide, please. So this is the sort of thing that irritates me a little bit when you see this on marketing materials. These kind of swirly lines or arrows that people stick on their stage 2 drawings. In my office, these are called lines of desire. As beloved of architectural students and even professionals, to be honest. Yeah, sort of showing air sort of autonomously kind of making its way around the house, cleansing every nook and cranny, and that's not really how it works from an engineering point of view. So in simple terms, we've got air moving from higher areas of higher pressure to low pressure, and it takes the easiest route to get there. Just gonna I'm going to persevere with the sound. Yeah, so air moves from areas of high pressure to low pressure, and it goes via the easiest route, and this is kind of central to some of my concerns about these particular systems. So yeah, we're blowing air in, it's got to get back out again somehow, and it's going to take that easiest route there. And one of the problems with that is we don't really have control over that directly. Certainly, we don't have control if we're not doing anything about it and designing something into the building to create these air paths. And the other issue that I will touch on is short circuiting. So next slide, please. So there's this issue of whether a loft is indeed a good place to put a fan. So these are mechanical pieces of equipment that do need maintenance. Occasionally you might see claims that things are maintenance free. That's just nonsense, frankly. They've got moving parts. Anything with moving parts does have a finite lifespan. But more importantly, actually, is the filters. And again, I've seen claims about maintenance-free filters, and that's just not a thing. They work by catching the crud from stopping it getting where it ought not to be by holding the crud in the filter, and they've got a finite capacity that gets filled up, and you need to change them out. Secondly, so is this a good place to be even drawing air from to begin with? I mean, on the left here, we've got the kind of loft that we'd all like to go and see as inspectors, but in the reality is often more like the one on the right. In my experience, if not mouldy, then lofts are at least quite dusty places. And filters aren't 100% effective, particularly the G4 filters, which are kind of designed to really just protect the equipment. They're not necessarily going to catch all the stuff that's bad for us to breathe in. And I'm also going to come on to the issue of temperature, which I think is on the next slide. So, one of the claims around PIV that we come across a lot is this idea that lofts are warmer in the winter than outside, so we get a bit of free heating. I'm kind of okay with that to an extent, but I think the real question is how much free heating do we get? I'm kind of comfortable with the idea that on average lofts are slightly warmer than outside. Whether that's kind of enough to be beneficial, I would question. One of the issues here is that while you get solar gain on there during the day, you're going to get radiant cooling at night, particularly when the sky is clear, and that loft is potentially going to be pretty cold. The more important issue really is what happens in the summer, because that roof space is going to get really hot. I have measured internal surface temperatures on the inside of a roof approaching 50 degrees Celsius on a hot day in the summer, and that's really going to contribute to overheating issues. Generally speaking, UK homes don't have air conditioning, so the only way that we've got to get heat out is by ventilation. And if one of your primary means of ventilation is basically pumping in even hotter air, that's a problem. So again, this is just stuff to kind of think about, and questions that need to be asked. I mentioned at the top, there are units with like a bypass duct so that it takes air in from outside, but it seems like a bit of a bodge. and there's just better ways of doing things. Next slide, please. So the final piece, and this is sort of more aligned with my specialism, is this issue around fabric moisture. So basically, what we're doing with positive input ventilation is to pressurize the house positively, and as I said, air is going to flow from areas of high pressure to low pressure. So we're basically pushing warm, moist air out through the fabric, which is basically a recipe for interstitial condensation. I've done some analysis with this in software called Buffy, which you might have come across, and that shows that, yeah, that could in some situations be a problem. I don't want to kind of over-egg that, all simulations are wrong and some simulations are useful. I think it's flagging that there's potentially a risk, but quite how severe that is going to vary a lot from case to case in reality. So this is just another, I think, open question, which I think leads me to my last slide, please, which is basically that we don't really know yet. We don't really have enough research out there about these systems. There's a couple of documents that are getting on for 20 years old now. So BRE IP12 is 12/00 is the key one that pulls together some research that BRE did on about 15 test houses. I think that was sponsored by obviously PIV manufacturers, so perhaps not entirely independent. But even that was indicating that we may be getting, for example, a lot of bypass back through the loft hatch. So we're blowing air into our landing, on a typical semi-attached two-story house, for example, and loft hatches are certainly before retrofit often very leaky. And so that's a very easy path for air to just go straight back into the loft without doing much good in the way of circulating through our kitchens and bathrooms and living spaces to get rid of moisture and to provide fresh air. So I think a lot of the stuff that I've mentioned very briefly here, these are, I would be first to admit, somewhat hypothetical, but they are rooted in science and engineering. These are kind of valid concerns, I think, and really just need more information about this and the precautionary principle to risk risks like this is really that we should either not proceed with this or proceed with extreme caution, and to really pay attention to our monitoring and get some technical monitoring into these projects where we're doing these things before we start to really roll this out on a large scale. But my personal view is that there's the sort of ways that are not significantly more difficult or expensive that just work better. I'd never say never do this kind of system, but there's a lot of concerns in my mind, of the questions that are somewhat unanswered about these kinds of systems. So there's one more slide, just a final kind of thought to leave you with, which is if it's not designed, installed and commissioned correctly, it doesn't matter which way around the fan's going. That's it. Thanks very much.
Toby, thank you very much indeed. Really appreciate that, and a nice little kind of closing statement that's hopefully going to stick. So much appreciated. Thank you very much. I am conscious of time. We've got a couple of people possibly still waiting in the meeting room. So good morning to anyone that is joining a little bit late. We're going to hand over now to our final speaker, which is Adrian. So let me just move that slide on. Adrian Hull. Let me just put it over to you, Adrian. And again, Adrian, just let me know when you're ready to move on to the next slides, and I'll take over that for you. But it's all for you, Adrian. Over to you.
Good morning, everybody. So hopefully we can see and hear okay. And it's not wanting to let me move there we go. That's working okay, Andy, so I should be all right. So good morning, I'm Adrian Hull. I am Director of Retrofit Solutions Limited, THS Inspections, and Chair of ATMA, the Association of Technical Monitoring Agents. Just briefly, who are Retrofit Solutions and why are we involved? Retrofit Solutions is a new company set up in May this year. For those of you that know THS inspections, the easiest way to describe Retrofit Solutions is if THS inspections are the referee or the VAR. For those who follow football, then Retrofit Solutions would be the coach or the player coach with you on the pitch or on the sidelines, trying to help you through the challenges of retrofit within the past 2030 and past 2035 sphere. So we are assessors, coordinators and evaluators, and we've got a range of coordinator support services to help people get compliant with past 2030. So Retrofit Solutions are also an approved contractor under the NIC Domestic Ventilation Competent Person Scheme, and created some services to help the supply chain, which we will look at the end of the presentation if we have time. But today is really about looking at practical challenges and scenarios that our customers have encountered in delivering real-life ventilation solutions in funded programs. So as a bit of an overview to start with, so what's it like operating within PAS 2035, in particular with reference to Annex C and reality? What have we seen and what have we learned so far? Well, it'd be no surprise to find out that every household is different. This is retrofit, after all. We're not going into properties that are a blank canvas. There are existing features. Some people may have had a go at ventilation in there previously, and we're dealing with a mishmash of existing and absent services, and we're looking to bring that property up to the correct standards to meet Annex C. And the first thing is, it's really important that the existing ventilation services are investigated properly and documented. Otherwise, the coordinator can't complete his ventilation assessment unless you're capturing that information thoroughly at that front end, whether that's via your retrofit assessor or a visit to the property by the coordinator themselves. You haven't got a chance in getting to a point where you've got a workable ventilation solution for that property. So far, what we've seen is, and it's a new area for a lot of installers, but what we've seen is a bit of an approach that mirrored energy efficiency measure installation under 2030-2017, where you go straight from a quite high level survey into an install in an attempt to have a one-size-fits-all approach without bespoke design or consideration of other unique circumstances in the household. And often it's where assumptions are made or information is missing. That's where the errors occur, and we get unintended consequences and non-compliance with PAS 2035. So obviously this is clear within the PAS itself. You need to use competent persons to ensure your ventilation solutions are appropriate, compliant and safe. And we shouldn't be forgetting the householder. So a lot of people are doing their best to get it right now, but what they're not doing is spending sufficient time with the householder to explain how to use the new equipment, what the maintenance requirements are, and to make sure that the relevant documentation is left in their possession, the user manual instructions, the minor work certificate, if it's been added to an existing electrical circuit. Excuse me, I've just lost the screen there. Let me get that back. And any building control notification. So overall, there's no single one-size-fits-all approach to providing adequate and appropriate ventilation. Like I said, this is retrofit. Every household is different and every solution may be different. So let's have a look at some real life problems and solutions encountered so far. So the first one is an example that we've come across on a number of occasions now, and that is where the installer wishes to, there's just some background noise there. If you can just make sure you're on mute, everybody, that would be great. Where the installer wants to include a decentralized continuous mechanical extract ventilation solution in a property where there is existing mechanical ventilation missing from most of the wet rooms, but there's already an existing externally venting cooker hood in the kitchen. It may be old, it may not be working very effectively, it may be working fine, but what do you do in that situation? Well, you'd really look to convert the existing cooker hood to an air circulating mode and fit the DMAV units in the kitchen and the other wet rooms. Why? Because intermittent and continuous fans are not compatible in the same space. They fight against each other, and they're usually not compatible in the same property. So you're either going for a whole house ventilation approach or an intermittent approach with appropriate background ventilation, which is known as System 1. We do see and come across quite a mishmash of different approaches attempted within a property. Secondly, if it was not going to be possible to adapt the existing cooker hood, or the householder would not let you do that, then you could determine if IEV, an adequately sized background ventilation, would be appropriate for that property in that instance. But you need to take into account which measures you're installing. So for example, if you're installing IWI and you're not completing 100% of the property, so you're not insulating the bathrooms and kitchens, then the BIS Guide to Best Practice would steer you down the route of requiring decentralized mechanical extract ventilation in those circumstances. You would also have to do a post-installation air tightness test to make sure that the property is not, or is still leakier than 5 meter cubed per meter squared per hour at 50 pascals. And obviously you'd need to make sure that there wasn't any existing condensation or mold growth, which would require a continuous ventilation solution with demand control that's ideally linked to the relative humidity to try and overcome that existing problem within the property. So that's quite a common one. The second example we've come across is, again, we've come across this on a number of occasions where people have wanted to ensure that there were adequate door undercuts on internal doors to meet the requirements of PAS, but some of the doors within the property are actually fire doors. A standard fire door is still permitted to have up to an 8 mil gap beneath it, which, whilst not quite meeting the 10 mil requirement, it is still enough to allow a ventilation system to operate effectively in most instances. It's really important that your assessors, if they're your eyes and ears as a coordinator on the ground, they need to be able to recognise and identify those fire doors. And you can modify them in some instances, but you must be an approved company. Otherwise, they would not retain the certification. So always consult the manufacturer's instructions and seek competent advice and assistance if you are going to start altering or wish to alter any existing fire doors. In some circumstances, you may have an FDS rated fire door that's present. These are typically have a cold smoke seal at the bottom. We would see them in our properties perhaps between the kitchen and utility and the garage, for example, but they are used in houses of multiple occupation where there's multiple bed sits. These should never be altered. They're built in a way to provide a greater degree of fire protection, and you can't alter those. In that instance, you may need to look at other ventilation solutions. So if you have got a house of multiple occupation, separate units within the building, then you might need to look at a different solution if the bed sits a single room heat recovery ventilation unit, for example, in each separate space. And just a little flag there at the bottom. If you're working in high-rise properties, you must always seek specialist advice, not only around the doors and the fire doors within the building, but the whole fire protection strategy. You've got to make sure that whatever you're doing, whether it's introducing new ductwork, penetrating or changing the outer fabric of the building, or some of the internal partitions that act as fire protection, you must maintain that throughout the whole ventilation system as well. So you need to make sure you get specialist advice. The third example that I've chosen here is traditional buildings. I'm a retrofit coordinator, and I've got a property in a conservation area. I'm not sure if I can just drill a new core vent for an extractor fan in a wet room, and I'm not sure if I can add trickle vents to existing traditional wooden windows. Again, this is relatively common, and it may be that the property is not of a great significance, but it exists within a conservation area, so it still needs to be considered. First off, you need to check with the local planning department or conservation officer. Some permit additional services such as ventilation, as long as they're not on the elevations facing the highway. Others require you to apply for permission or certificate of lawfulness to assess and determine whether that is classed as permitted development. We would always recommend the latter anyway when you're working in a conservation area, because it protects the property owner, the designer, the installer, the retrofit coordinator from any future claims. It would be a mistake to proceed with the installation of a new ventilation fan on a facade that's facing the highway, because it could be a planning breach. So don't do that without first investigating whether that's permissible. If you're in a situation where permission's not granted or it's unlikely to be granted, you need to look at other ways to provide extract ventilation. So could you do it through a whole house approach with a central mechanical extract ventilation unit with ductwork terminating on an elevation that's not facing the highway, or perhaps even vertically through the roof space? You know, could background ventilation, rather than affecting any traditional windows that are in situ, be provided on the ground floor through floor vents, which aren't ideal? They're not the first recommended solution, which is to have the background ventilation above 1.7 meters so that it doesn't cause unnecessary drafts. But they are unobtrusive, and they would use existing subfloor ventilation to provide some controllable inlets. So there are solutions there too for traditional buildings. And the last example we've got is an open fluid solid fuel burning appliance in the kitchen. So it may be a log burner or an open fire or a range, and the kitchen's got no extract ventilation. You would be rightly concerned that installing an extract fan might impact on the appliance's safe operation and the combustion. What should you do? Well, the first option would be to decommission the open fluid appliance or convert it to a room sealed, which is probably not going to be popular with a householder and probably not your chosen option. So it's a difficult situation. On the one hand, you need to maintain safety for the appliance. On the other hand, you need to try to ensure that you're compliant with the ventilation requirements. So if the householder wants to retain that appliance and you need to put additional extract ventilation in, you need to talk to a specialist designer. Any newly installed system would require in situ testing and adjustment to make sure that that's combustion was still safe and achievable, and it would need to be undertaken by people who are both competent from a domestic ventilation perspective and a Part J perspective in terms of combustion safety. So what example from Ireland that Simon gave me the other day was where an additional combustion core vent was strategically positioned between the appliance and any extract fan to help overcome any combustion spillage and allow sufficient background air such that you could still have an operating fan within the space without impacting on the safe operation of that appliance itself. But whatever you're doing, and whether the open fluid appliance is in a wet room or even in a room adjacent to a wet room, if you're fitting a fan, you must always test that appliance and have that done by a competent person to make sure it can continue in safe operation. So just briefly before I wrap up, how can we help? We've launched a range of services. I'm not going to go through them in detail. There is a link there to our website and our ventilation check service. There's a free element to that, which is an online ventilation assessment tool. It's about gathering all of that information at the front end to make sure you've got the information to allow a coordinator to start to look at an upgrade plan, and it gives a package of information that you give to a designer. There's a few good links on there too. And these are just some example screenshots from the tool itself and the outputs. You get a quite clear ventilation check assessment certificate, which tells you whether the property's adequate or not, and if not, where it's not adequate and in what rooms. And if you go on to order the upgrade plan, you can get some calculations. The example shown here is for the background ventilation requirement for the property. So thank you very much for listening. Obviously, I'll be around to take questions with the rest of the guys, and I hope you've enjoyed the presentation.
Adrian, thank you very much indeed. That's fantastic. We've managed to claw back a little bit of time. I'm conscious that we have run ever so slightly over on the speaker side of things, everybody, but hopefully you found that of real value. Okay, so we did promise we'd go into kind of questions now, and my colleague Emily has kindly been sort of collecting some of those that have been being posted so far in that first hour. So Emily, if you're on hand, I think it'd be quite good if we can get you to unmute, and we can get our speakers to kindly put their cameras on and unmute, and we can go through some of the questions. If anyone's feeling brave enough, feel free to use your virtual digital hand that you can use on the Zoom function. We can kind of go around the room as well. So Emily, do you want to go to the first question?
Absolutely. I will apologise as well. Technology doesn't seem to want to work with me, so I can't put myself on camera. So I do apologise. You will just be listening to my voice as I reel off a couple of these questions in advance, and I might call on you if you're in the chat as well. So just to start off with then, we did have a few questions pre-submitted. So this may be open to our guest panellists today, and do feel free to jump in. So first we have from Julian Williams. I am unfamiliar with PAS 2017. However, if EWI was added to a property under this regime and as a result areas of black mold developed, is the contractor liable? Note that no ventilation assessment was done prior to the EWI work. Also, perhaps worthy of note is that although black mold is, I believe, still classed as a statutory nuisance, the occupant owns the property, so is the deterioration solely the contractor's responsibility? Bit of a long one there, gents, but anybody like to have a go?
I'll chip in if nobody else wants to take that curveball. I believe it was still a requirement to assess and upgrade ventilation under 2017. The circumstances were slightly different. It just wasn't as widely known, and it wasn't as normative as it is, shall we say, in the new PAS. So in terms of being compliant with that standard, there may be a challenge there. In terms of liabilities, that's an area I wouldn't want to drop into. I think it's a legal consideration really, and not one for us as panel members. But in terms of doing the right thing, EWI is a measure where you're cloaking the whole building. You're impacting the air permeability without a doubt. and obviously any ventilation consideration should be central to that approach going forward, both to maintain what's there and enhance it.
Thank you for that, Adrian. Thanks for giving that a go for us. I think that's yeah, definitely not one to get into the legal side of things. Is it definitely one to consider? We'll move on to the next question then. This one was from Phil Neal, which was submitted prior as well. So, I mean, not that we have a member of Bayes Trustmark, ECMK or BS actually on the call, I don't believe today, but he has asked someone who can actually make sense of the PAS 2035 Annex C, in particular point C 2.2. He advises that himself and his colleagues have been left with no choice but reject so many jobs, even just for loft insulation, where background ventilation does not exist. Having so many jobs rejected as a result of ECMK's interpretation of PAS, who in turn impose their interpretation on the retrofit coordinators they are currently using. So that's quite a large figure of the insulation industry. So I think really, you know, anybody that could make sense of the PAS 2035 Annex C 2.2. I mean, I'm not sure if any of you gents may be able to take that one on.
Sorry, I'm just trying to find the question written in the chat so that I can try and get my head around it.
No, I can send it to you if you like, Alan, or Phil, by all means, do unmute and explain it further. Absolutely.
Carry on.
I think that's next question, Emily.
Nobody brave enough to answer then.
Andrew Cunningham, I can see your hand up. I mean, by all means, if you'd like to chip in, this is all about discussion, so absolutely.
Yes. Can you hear me?
Yes, we can.
So just I do the same thing when I go to a house and we want to put a bit of loft insulation in, and I warn them that, you know, we're going to have to do undercuts, blah, blah, all the bits and pieces. So I just wanted to challenge or ask this question, which is, most houses that we see pre-1970 in terms of SIBSI are saying it's about 1.5 air changes per hour, which is, what I can make out is 3.9 meters cubed per square meter air change, compared to 0.25, which is the minimum. So it looks like quite a lot of houses that we see when we walk in, and they say that they're leaky houses, you know, this is what the house order says. They say, oh my God, I live in a leaky house. And I say, well, yes, maybe you do. And it's a factor of 15. So the current leaky house is 15 times the minimum. So we've got 3.9 compared to 0.25. So what I don't quite understand is when we go in and do a small change to a house, let's say a bit of double glazing or loft insulation, we then have to put more ventilation in, when actually the starting point is that the house is 15 times more ventilated than the minimum. That's my question. Why do we actually technically need to do that when we're walking into so many houses that already have this very high background ventilation rate?
I think the first one on that would be to comply with building regulations. So building regulations say that you can't make anything any worse. So in terms of the air tightness, you're introducing a measure, whether it be double glazing or loft insulation, you are reducing that air tightness.
Yes.
In those instances, you would need to test and show that the existing air exchange was not reduced to a point below which you could operate, for example, IEV as a proposed solution. You don't really know without testing. Okay. I've done it on several properties. I used to run a program in Canada with a grant scheme, which was a rebate scheme, which was based entirely on improving the air tightness of properties. I've seen enough and done enough to say that you can't guess, because Mrs. Miggins, insulation. Even with loft insulation and the effect's minimal, the one thing I would say is the new Part F, which was published yesterday, does take a slightly different approach to lower risk domestic retrofit in existing dwellings. So there is a mechanism within the new Part F that gives a bit of grace for lower impact measures like loft insulation if they're done as a standalone measure. The challenge you've got is, one, will the PAS adapt to that now that's been published and changed, because the PAS is going further than building regulations. And secondly, we're moving towards whole house retrofit. So we should really be looking at combination of measures that together will make a difference. And while we're doing that, we need to move from uncontrolled adventitious air, because if it can come in that way, the moisture laden air can get back into the building fabric the other way. So we need to concentrate on making the building as airtight as we can, but with those controlled outlets for moisture laden air.
But we're already working with buildings which are so leaky in the first place. This is what is hard, and householders just sort of laugh at you when I go in and they tell me that they've got the leakiest house in the world, and I say, I'm sorry, but but it's not leaky enough, and we need more ventilation. I mean, it's not a great sell to go to a house and tell them that they haven't got enough ventilation in their houses. Not only on self-reporting, but on this the actual mass of it. It looks like they've already got 15 times the minimum anyway. 15 times, not just a bit more, but 15.
Thank you.
Come in on that point.
Fabulous. Yeah, I was just about to hand over to you, Tom. Actually, I saw your hand up, and Alex, if you did have input, and Toby as well, please do feel free to follow on from one another afterwards.
Okay. Well, thanks, Emily. Look, there are two aspects here. First of all, every EEM will impact air tightness and therefore will impact the ventilation requirements somewhat. So that's true. Having said that, because the ventilation requirement at the moment is so blunt, we end up with idiotic outcomes where, for example, the house may have an air tightness of 9 and people whack MVHR in it, which effectively doubles the thermal loss from the property overnight with additional electrical cost attached to it. If there was something a little bit more intelligent, maybe like a sliding scale of air tightness, where people installing EEMs could actually justify their choices based on the actual status quo on site. So if the building has an air tightness of 3 after you've installed your range of EEMs, then you would need to have a whole house balanced ventilation system. But if you're somewhere in between, 3 and 6, it might justify continuous extract with some sort of, inlets such as trickle vents or core holes or whatever, but probably on the, at the lower end. If the air tightness was 15 to start with, you put in loft insulation and you suddenly 13, why can't we just have a sliding scale where we can do a blower door test and say, this is the air tightness after we've installed the EM, whatever that EM might be, and this is the solution we're proposing. And if you're at 12, technically speaking, a broken intermittent extract fan is still there because you live in a tent. If you live in a tent, you don't need a fan, right? You only need something when you're moving closer to a submarine level air tightness. And having an intelligent sliding scale range of solutions available to energy efficiency measures suppliers to actually, point with there, therefore either this is the action required or no action is required because the property is already ventilated plenty, would make it so much easier and also less idiotic. At the moment, as Andrew said, we're having to go around and drill, 100 mil core holes everywhere in order to install underfloor insulation. And people just, kick us out of the door immediately because their objective was to have a warmer house. They've still got single glazed windows. They've still got solid walls. They just don't want to freeze their feet off in winter. And we're up to installing massive draft. And it just doesn't make sense if the property is, has got air tightness of 15.
Can I say something?
Absolutely, Phil, do go ahead, and then we'll pass on over to Toby and Dean, who've got their hands up as well.
Sorry.
No,
What Tom just said, I thought was brilliant. we also, to add to that, we go to properties that are massively underoccupied. So you can go there where there are kitchens and bathrooms that don't have a single extraction fan anywhere, and there's not a spot of mold in the grouting, on the tiles, on the ceiling, anywhere at all. And we're stood there, as Andrew said, trying to convince these people that they've got to have trickle vents on the windows or whatever it is, in order for us to be able to do this work. It's insane that we are pushed down this road. For us to go to the expense of trying to do a pressure test on that property, the equipment is excessive, especially if you go for a 4-bed detached house. You need 2 of them. They're £6,000 each. That's an awful lot of money to spend out on just to put some loft insulation in. And when you're doing loft insulation, in most cases, all we're doing is improving what is already there, as opposed to starting from ground zero where there's no loft insulation. Because I do on the odd occasion, but I have to say it's a 0.1% of an occasion going to a property where there's currently no loft insulation at all. Otherwise, we're just improving what's already there. Now, if that person or that elderly couple living in a 4-bed detached house or 3-bed semi, it's underoccupied, they don't create enough moisture for us to worry about. So I think if we had some kind of sliding scale, but not with pressure testing the property, common sense has to reign somewhere.
Thank you for that, Phil. Toby, if I could pass on over to you. I've seen your hand up for a little while.
Trying to improve my sound. Hopefully that's a bit better now. I'll speak up as well. But so I'm not very familiar with PAS 2035 and that whole approach. And I suppose it's just, we do stuff as consultancy, outside of that PAS 2035 system. It's really about sort of taking a sensible approach to risk. I think that's the lens through which we do a lot of our work, and I think I just would echo what Tom was saying about, it needs to be a sensible approach, and even what Phil was saying, perhaps we don't even need to do an air pressure test, but I think we need to acknowledge that as professionals, that it's absolutely fine to make judgments. That's where designers add value to the process. But on the other hand, you need to acknowledge that that there's a responsibility there. And one of the sort of dichotomies, I think, of the kind of PAS sort of setup, where it tries to be extremely prescriptive, and you end up with these slightly silly situations where you have to, do expensive ventilation systems or whatever when you're just trying to talk about the loft insulation. You get these sort of slightly silly outcomes. The flip side is that maybe we need a bit more flexibility in PAS 2035 so that we can make these sensible judgments, but ultimately, who's taking responsibility for that? I personally am comfortable to say, you don't need to worry too much about insulation because the house is really leaky. And I think there's a sort of a protocol system level issue with how that gets resolved when we're trying to retrofit 25 million homes. The other thing I just wanted to chip on with that, from that perspective of kind of personal accountability and professional responsibility, given that bit, there's a really great tool by the STBA, the Sustainable Traditional Building Alliance, called the Retrofit Wheel, which details a lot of the interactions between the different measures. So that's something a lot of people are familiar with already. If you're not, then I recommend you go and have a look at that, just for interest, even if it doesn't tick the PAS boxes.
Thank you, Toby. Dean, if I could pass on over to you now, and then we'll go on to Simon afterwards as well.
No, thank you very much. I did put a question on the chat. However, I thought I'd raise my hand and just ask the panel directly. And my question is in relation to when the ventilation strategy adopted is intermittent mechanical extract ventilation. Part F of building regulations talks about an air permeability test to show that the air permeability of the building is above 5. And there are 2 separate tables for background ventilation. So my question is it required by a retrofit coordinator to record that an air permeability test is being conducted in order to use the lesser provision of background ventilation as per, I think it's table 5.2A?
I think C3.3 covers that one in the PAS, and it does say it's required. It says shall be tested, and it tells you the British standard by which it's got to be tested. So I think that sits within Annex C, and I think it states that reasonably clearly.
It does, Adrian. Yeah, in fact, my question was, is this actually being conducted and recorded from a retrofit coordinator perspective, and how is it being audited?
Well, presumably you'd upload the pressure test results certificate with everything else that you're uploading.
Great, thank you very much.
Thank you for that one, gentlemen. Simon, you have your hand up if you'd like to input anything.
Yeah, can you hear me? Did I just unmute myself?
Yes, we can hear
Yeah,
you.
so yeah, so I suddenly appeared on the screen. I was up at the top. Yeah, it was just a short comment. There's a lot of experience here in retrofit, and I think one of the things we have to be careful about when we're reflecting on the standards is straw man arguments and extreme cases making poor law. We can all cite examples of properties that are incredibly leaky. We've really struggled with situations to justify ventilation. But there's an enormous amount of the building stock in the grey middle ground that these standards really do add strength to. There are an enormous number of turn of the century buildings that are surprisingly airtight, and it's amazing how many small measures can have very big impacts on indoor air quality. It's also amazing how many properties are currently under-occupied that within a year could be over-occupied. There are many properties that when we improve the insulation and thermal comfort of properties, suddenly make the entire building more livable in, and we find spaces being occupied and used that have never been used before. That's one of the key values of retrofit. So it's just caution that, I think there needs to be flexibility with professionals to deal with the outliers, but we must remember there's an enormous amount of the stock that we're talking about here that's in a middle area that, if left unchecked, it goes back to one of Peter Rickaby's points. You don't want to create cases where you're incentivizing measures that are poorly thought through. For example, keeping a building a bit leaky to avoid a ventilation strategy, or making decisions about to sit within certain grant systems to avoid, or sit outside of certain grant systems so you don't have to deal with certain measures. It's just something to be careful of.
Thank you for that one, Simon. I have another question from the many in the chat. So actually, this one's from Adam Edge, and I'd like to invite you just to sort of expand on your question. I think it was in response to Alan's presentation at the very beginning. If you wouldn't mind unmuting, if you're there. No? Okay, in which case then we'll move on to the next one. This is okay, from Hamish McMichael. Can you please explain why SRHRVs cannot be used to design a whole house system? There are some interesting products available in Germany, such as Jet Air and Lunos.
I don't think we can comment on particular products. We can only comment on the principle. And the principle is that single room heat recovery ventilators don't give you whole house ventilation. They're not providing what you want in terms of fresh air in the habitable rooms and extraction of moisture rapidly from the wet rooms. So they have their place, but not generally as a whole house system. That doesn't mean there may not be products where that may not be true.
Thank you for that one, Alan, there, brilliant. And moving swiftly on to the next, then, as we do have quite a few questions. From Stephen Mulverhill, we have, is it acceptable for retrofit assessors to carry out ventilation surveys? I always understood that this must be carried out by a competent person. I have checked with the NIC, EIC, and they say for anyone who has completed the domestic ventilation course and have been accredited by themselves, they will be allowed to complete a domestic ventilation certificate pre and post installation. This includes specific PI insurance, acceptable testing equipment, which must be fully calibrated by UCAS certification and continuous monitoring of the competent person. So I think just the general question there is it acceptable for retrofit assessors to carry out ventilation surveys?
I think it depends on the definition of the term. I mean, it's a requirement for a retrofit assessor to do an assessment of the ventilation of the property, or at least to collect the information needed for the retrofit coordinator to do so. There may be a different interpretation of the term ventilation survey in the context of the design. I'm not sure, but it's certainly part of the assessor's job to do the ventilation assessment part of the retrofit assessment.
Fantastic, thank you. Moving on then, from Peter Marsh, why are single room heat recovery ventilators not allowed to be used as a whole house system? This is done widely in Europe and allows a much easier install without the need for ductwork.
We've just done that one, haven't we?
Yeah. Oh, sorry. I do apologise. Pretty much, yeah. So, okay then, lovely. I've got another one here. So, when the ventilation strategy adopted is intermittent mechanical extract ventilation, IEV, should an air permeability test be conducted and recorded as part of the retrofit coordination process? So a lesser provision of background ventilation can be installed as per table 2.5a of part F. Is this being audited?
I'm afraid I don't know what's audited or not.
Oh, sorry, I think that was my question from previously before, yes.
Wonderful, okay. Yeah. So we're going back on ourselves now. Okay, wonderful. I've got a few more here, though. That's not to worry. Sorry about that, gents. Okay, will the location of the home also impact the ventilation strategy? For example, by the sea, different to a city location?
Yeah, there's an enormous number of factors that can influence the performance of a ventilation system, particularly natural ventilation, orientation, stack heights, where the building is located, topography around it, its geological location, its position within Europe, prevailing wind directions. All of these things have massive impacts. There are also, of course, impacts between urban and rural divides, pollution levels, location of vents next to roads, for example. All of these things should be taken into account. Another thing that is often missed, just to add to that, is that often when we're retrofitting buildings, particularly when we're looking at deep retrofitting, we are significantly improving the sound performance of the fabric of the dwelling. And if you don't consider location of vents when you do that, you then create a source of sound that wasn't there before, or is much more noticeable. And that can have an impact on people's use of those vents. So all of these things need to be thought of in context, and that's where experience and sitting back and having a look at a property, where it sits, how it's going to be used. And I'd refer you really to the 4 Cs that's espoused by Peter Rickaby and others a lot around looking at context and cohesion and capacity to really understand whether that ventilation system is going to work in that particular situation.
Thank you for that there, Simon. And we'll move on to another question then. So what do you do if there is nowhere physically possible to put MEV in the kitchen, i.e., for example, a mid-floor flat with no wall space for the fan? So essentially the window basically covers the full wall within the limited space.
I have never come across a circumstance where you haven't been able to put some form of ventilation into a space. It may be messy or complicated or expensive or difficult to do, but you should always be able to ventilate a space, and that's the challenge. If you have an unventilated space that should be, it needs to be dealt with. And that's where dealing with experienced ventilation professionals that have seen 1,000 different solutions over their time, they will be able to pull or draw from something to find a way of doing it invariably.
Fantastic, thank you. Moving on to the next question then. Okay, so this one is actually directed to Adrian Hull. So in relation to your example number 2, the smoke door is a known issue in Scotland. The fire regulations for smoke doors are slightly more onerous. The requirement for ventilation has been addressed by Scottish building control departments by allowing 8mm over 3mm gap, but there is a requirement for additional smoke detectors. And referring to Labs Info P24, this is a specific enhanced fire detection system. Would this be an applicable approach in England?
So it may be, but I'm not a fire protection expert. So I would look to, as a retrofit coordinator, look to consult with somebody who is, and look to get that balanced solution in place. The ventilation check service is for England only at this point in time. It can be used in Scotland, but it does caveat quite heavily that the technical handbook is quite different to Part F. And you should have local advice and specialist fire advice before you look to do anything with anything that changes the integrity of the structure or fire protection. So I would default to a fire protection expert on those issues.
Thank you for that, Adrian. And I do actually have another question back to back for you, if that's all right. So this is from Frank Crichton. In relation to your vent check screenshots, the building standard in Scotland are to change in the new year. These will have different values to the values indicated based on English building standards. Can the values be adjusted to take account of this change in the standards?
Yes, they can, and they will be anyway, because come June 2022, the new background ventilation requirements in Part F will change as well, and they will get aligned to the current requirements up in Scotland. So particularly for a single-storey dwelling, the requirement increases per room, per habitable room, up to 10,000 millimetres squared. So there's significant changes coming in next year. And the check service is adaptable and will be changed as per the requirements. Obviously, we've got 2 sets of requirements then. We've got what PAS says and we've got what Part F says. So there is, and I have flagged this to BASE and the PAS steering group, that there will need to be a coming together of minds when that change happens to make sure that they're not further out of sync than what they are now.
Fantastic, thank you. Sort of a direct for Toby. So this is from Dino. I'm struggling to agree with your thoughts on PIV. Would it not be that the air would leave the property through the path of least resistance? We are installing trickle vents in every room and ensuring door undercuts throughout. Surely this would be the exit path, would it not? Whilst I agree that further checks need to be completed, should it not be that this is completed further before we strongly suggest that this isn't used? I've been driving for many years, and when the interior of my car windows condensate, I turn on my air blowers, which are basically PIV in a car.
Yeah, I mean, I agree that the air will leave by the path of least resistance. I think I said that quite specifically in my presentation at least once. I think the point really is that where is that path of least resistance, and especially in the context where we talk about homes with potentially air tightnesses exceeding 10 meters cubic per square at 50 pascals. Where are those leaks? And we basically don't really know without spending a lot of time going around with a smoke pencil or whatever. And even then, you can't really pin it down. It's very difficult to engineer that kind of system to do what you want it to. So I don't know if this is a useful analogy, but if you have a ping pong ball on the table and you have a bit of string on it and you sort of pull it, you can control where it goes by putting the string in whatever direction. If you try and push that with a pencil across the table, it's a completely different story. It wants to go off left or right. It's a convergent rather than a divergent system. So let's say possibly an imperfect analogy, but the point being that if we pull air out through our wet rooms where we're generally generating the most moisture, we're dealing with that moisture at source, and we can be more confident that we're achieving the air changes in the particular places where that's most important. I said, I'd never say never. You need to, take responsibility for those choices. If you're confident that you can achieve those airflows in the specific places that you need them to, if you come up with a design and selected some ventilation rates for different rooms, and if you can measure those and show me that that you're achieving that, then brilliant. But I think there's an awful lot of work to get there compared to just going for some decentralized continuous extract fans, for example.
Thank you.
Sorry.
Is it all right if I just add one thing? It's important not to think in straw man terms and in binary terms here. It's not a case of either or with airflow. It doesn't matter whether it's extract or negative pressure systems, positively pressure systems or balanced systems. You will have a proportion of air that will always flow through a vent, and a proportion of air will always come through leaks in the building. That's just the way it is. So even in a negatively pressurized system, in a fairly airtight dwelling, a majority of the air will come in through the extracts, but some of it will always come in through the fabric of the dwelling, and vice versa in a positively pressurized system. Even if vents are perfectly placed and you've got undercuts under doors, it doesn't stop some air going through the fabric of the building. It's not an either or scenario here. And when we do modeling of ventilation systems, you will always account for both air movement through leaks in the building and through purpose provided ventilation opes, regardless of the pressurization of the system.
Thank you.
Can I just add as well something to that, Emily? So it's a lot of retrofit coordinators on the call. So putting my retrofit coordinator hat on here, if I was to specify as part of the ventilation upgrade plan PIV for a property, I've got to satisfy myself that I can comply with the requirements in Annex C of PAS 2035. So there are several requirements relating to achieving compliance with building regulations. PIV is not a recognised system in Part F. It's what's known as an alternative strategy. Therefore, the route prescribed for claiming compliance with building control and leaving the householder with a notification certificate to enable it to be legally valid and have it tested by a competent person doesn't exist through the traditional routes of the competent person scheme. You'd be going through a different route via the manufacturer and local building control. and then having to pull that information together and be confident that you're signing that off as the coordinator. You're in charge of Annex C, PAS 2035, not the installer, that you're complying with all of those requirements. Personally, I wouldn't be recommending PIV in the vast majority of cases. I do see the odd occasion where it may be the only solution, but in the majority of cases, it's a difficult compliance route, and it can be, we don't know that it's not going to do future damage to that property in terms of driving moisture into the building fabric.
Thank you for that, Adrian. Absolutely. Moving on to our next then. Actually, this is from Julian to Tom Lipinski and Phil Neal, if you're still on the call and would like to respond. So why is draft proofing not being advised to clients as one of the first and easiest early moves to make before loft insulation? It is a low-hanging fruit. All RCs should understand this, as well as the distinction between ventilation, which is essential, and infiltration, undesirable and so not to be reduced. The idea that one can sidestep suitable ventilation because the home is thought to be leaky is almost certainly, at the very least, a high-risk strategy. Gentlemen, if you wouldn't mind commenting on that, if you are still on the call.
I'll probably start. First of all, I totally disagree with the language used in this question. We're not talking about sidestepping appropriate measures. We're talking about actually doing what's appropriate for the dwelling at its stage through the retrofit process. In very many cases, you've got single measure providers that are contacted by, let's say, private homeowners and others to provide a single measure, okay? And even though we are talking about moving into the whole house approach and so on, we still have millions of private homeowners for whom that journey might take 20 years. You know, we've got millions of homes that might go through 3 or 4 ownerships while they're continuing the journey to being fully retrofitted. So if you're a single measure contractor, just so let's say, you know, people want to insulate a floor because it really bothers them in winter that they actually can't use the ground floor of the property, and they feel that as a value for money investment for them. And the house is a, you know, untouched Victorian dwelling. To drill core holes in every habitable room for that particular dwelling is not an appropriate ventilation measure. It's the opposite of that, okay? And they might not consider solid wall insulation, or they might not consider, you know, replacing windows for another 5 years, okay? Are we to refuse them using their house the way they desire? Are we to refuse them starting that journey through the retrofit process just because the ventilation requirement is so blunt? It just feels idiotic to do that. So please do not say, you know, do not make it a binary question like, oh, we're trying to sidestep ventilation. No, we're trying to do what's appropriate for the dwelling at this point in time, because there might not be another measure for another 5 years, right? Why increase the heat loss from the property just for the sake of ticking the box? What we're trying to do is reduce that. So if we're trying to follow science, okay, we're trying to be proportionate to what we're doing to the building. If we were given an option of doing a blower door test at the end of the job and saying, okay, we finished the job, it's airtightness of 12. Therefore, on a sliding scale, it lands here. Therefore, what's in the house, it's either appropriate or not appropriate, or what we're introducing to the house, because you can very easily calculate, you know, if it's airtightness 9, in order to provide it with the right, you know, amount of air exchanges per hour, you need to introduce this equivalent opening area into different rooms. And it's not 6,500 millimeters squared. It might be 2,000 or whatever. It's about being proportionate, being appropriate, being sensible, and following what's best for the dwelling at the moment in time. Because whole house retrofits will do for social landlords fine. People have the budgets, they'll follow the full design. But we have 20 million homes here that are not owned by social landlords, and these people will want to cherry pick certain items. And who are we to refuse that to them? Who are we to be dogmatic in our approach? If somebody wants new windows, or somebody wants a loft insulation, or somebody wants floor insulation, we should be able to provide the scientific evidence, the factual evidence to Trustmark after the job, saying this is the airtightness of the property, and this is what we have chosen as the most appropriate way forward to tackle indoor air quality and, you know, fabric safety and de-risking. And at the moment, we don't have that tool. At the moment, we're being treated like total idiots because it's either yes or no. And it just feels like we're imbeciles, and it's counterproductive. Thank you.
No, definitely. Thank you. Thank you for that insight there, Tom.
Can I just expand
Absolutely,
on one thing?
Neil. Of course.
So the bit about going to somebody's property currently in their own situation, the past 2035, when we've started to talk to our current retrofit coordinators, they say that we have to look at the property from a future perspective as well as a current standard. Well, I sort of disagree with that, because currently, as Tom's just said, the existing resident of that property wants to have the roof insulated because they believe that's going to be best for them. We go along, we assess, we agree or disagree with them. We put forward a proposal for some measures to be installed, and it's their property. If it's under occupied, that's the way it is right now. If that person then leaves that property, the new people moving in will then make their own decisions of what to do with that property, rather than us trying to forward think 5-20 years of what might happen in the future, and there'd be a complete family in that property rather than a retired couple. The other point for Julian is the bit about draft proofing. I agree, draft proofing is a very important measure in terms of trying to reduce airflow and increase the air tightness in the property. It is important. In fact, many years ago, when I first started in this industry, some of you here may remember there was a scheme called the Home Energy Efficiency Scheme, and that did nothing more than draft proofing and loft insulation to people's properties. Government funded and worked extremely well. And I don't remember anybody ever coming back to me and saying, I've got condensation in the property. Thank you.
Thank you for that, Phil. I would look to wrap up, but I can see Alex Hunt's hand up. So if you would like to speak, Alex, and then we will look to get any questions left unanswered back to the individuals that have asked them. Myself and my colleague Angie will be looking to do that. So if you do have a question, it hasn't been answered today, we will look to get back to you, hopefully before Christmas next week.
Thanks, Emily. Well, my big thing really is to back up Tom and what he was saying as well. I mean, a lot of this talk is I think what people misunderstand is that we're looking at a whole house retrofit solution. The trouble is building work doesn't actually happen like that in a lot of instances. You have single measure installers, you have plasterers, you have electricians, you have window fitters, you have external wall insulators. And what they tend to do is focus entirely on what they are doing. And the role then of the retrofit coordinator is to make sure that when those single measures are introduced along with other single measures, that they are all working in cahoots with one another and not against one another. And that is really a very key thing about all of this. And again, I think also to point out that, yeah, this is other people's homes. It's the most expensive thing they own. It's the most money they've probably ever spent. And if you go rolling in there and tell them exactly what they must do to their house, you'll see yourself rolling straight back out of the house again. So if we are going to get anywhere towards these 25 million houses to be retrofitted, you have to involve the householder in exactly the way they want to do it. What you also have to do is present the risks that may be possible if you install certain methods of improving insulation or improving airtightness, and those risks need to be carefully considered, followed up, examined and mitigated against if at all possible. And if the risks are terribly high, then you are saying to the householder, look, these are the risks. If you take this on, this is my point. You know, I'm the expert here, or we're the experts here. We tell you that if you do it like this, there's going to be a huge risk to your house. And if the problem then persists, then unfortunately it's your house, that's your problem. But I think the key thing here is to remember that this is about a whole house retrofit solution, not single measures. And the whole point about ventilation is that once you have improved other areas in terms of air loss and and heat loss, then the ventilation is key to make that property still a livable space. So there's my 2 pence.
Absolutely. No, thank you for your input, Alex. That's
just one statement. Is anybody here from the double glazing industry? Because I've been to several properties just recently where they've just had brand new windows installed and there's not a trickle vent in sight. So why are they not being assessed in the way we are?
They're not spending government money on retrofit.
Mm.
Fair point.
Yep.
I will have to look up to wrap up now. Thank you to everybody who has attended today, and thank you to our guest speakers as well. We will be uploading a recording of this to our YouTube channel shortly. So if it is that you joined a little bit late or you'd like to pass on to your colleagues to review this, then that will be available shortly, and all will be posted on our socials as well so that you can catch up with us. So yeah, thank you so much, everybody, and have a lovely rest of your day and a lovely Christmas break.
Yeah, great job, Emily. Thank you very much, everybody, and thanks again to our speakers for today. It's been a really good, interesting debate and discussion. I have put a couple of links in the chat if you want to have a quick look at that before you leave the discussion. There's a few things in there about our awards, about funding, but also about our new LinkedIn group. We've set up Explore Retrofit, so we can carry that conversation online there with one another. So yeah, as Emily said, thanks for joining us today. Enjoy the festive break, and no doubt we'll see you all in the new year. All right, thanks very much. Goodbye.